Today we start Chapter 2, and we're going to start with 2.1 on relationships between two categorical variables. So we have some goals for today. At the end of the day today, you should be able to distinguish between explanatory and response variables for categorical data, which is kind of like independent and dependent variables in algebra. You're going to need to be able to read a segmented bar chart to display the relationship between two categorical variables, and determine if there is an association between two categorical variables and describe that association if it exists. So we're going to start by talking about the relationships between two categorical variables. The first step in being able to describe a relationship is to determine which variable is the response variable and which variable is the explanatory variable. A response variable measures an outcome of a study. An explanatory variable may help predict or explain changes in a response variable. In some relationships, there isn't a clear explanatory or response variable, and I'm going to give you an example of that today as well. So let's look at a couple of examples. Let's start with A. Let's say I wanted to collect some categorical data on your opinion about tax reform and compare that to your political party affiliation. We want to think about which one could predict the other. The explanatory variable here is political party membership, because knowing what political party a person belongs to will help predict that person's opinion about tax reform. So if you want to compare this to independent and dependent variables here, political party membership would be the independent variable, and the opinion about tax reform would be independent variable. That should say B there, sorry about that. For B, anger level and whether or not a person has coronary heart disease. So think about which one we could use to predict the other. The explanatory variable is anger level, because this might help explain whether or not a person develops heart disease. For some relationships, there isn't a clear explanatory or response variable. For example, in the relationship between eye color and hair color, either variable can be used to predict or explain the other. There's not a clear explanatory or response variable in this example, and so sometimes there won't be. After we've identified the explanatory variable, the next step is to display the distribution of the response variable for each category of the explanatory variable. This can be done with side-by-side bar charts or with segmented bar charts. The segmented bar chart is what we're mostly going to focus on in this class. A segmented bar chart displays the possible values of a categorical variable as segments of a rectangle, with the area of each segment proportional to the percent of individuals in the corresponding category. So that's a mouthful. Let's actually look at an example. So we collected some data here from some students that displayed the relationship between gender and preferred superpower. We've got a side-by-side bar graph there and a segmented bar chart there. One of them is putting superpower on the x-axis, and one of them is putting gender on the x-axis, so pay attention to that. So let's talk about how the data was collected. 200 students from the UK were surveyed about their preferred superpower. This is categorical data, so a bar chart is appropriate for that data. We can calculate the relative frequencies. Remember, that's just telling you percentages for each gender, because gender is the explanatory variable. Gender is our explanatory variable here. The side-by-side bar chart takes the explanatory variable and splits it up. So in this case, we take gender, which is the explanatory variable, and split it up into male and female. And I always apologize during this time for using gender so frequently. A lot of the studies that are done by scientists are split up between gender, and it can be hard to find ones that aren't. I do my best to try to incorporate ones that don't include gender. So we create this side-by-side bar chart to display the relationship between gender and preferred superpower. So just some examples, we can tell that females and males prefer invisibility about the same amount, but men are much more likely to choose freeze time or super strength, while women are much more likely to choose telepathy or flying. We take those bars from the side-by-side bar chart and we stack them to create the segmented bar chart. So you can see we've now changed this into male and female. All those bars for the female are stacked together and they total 100% because that's everyone that was surveyed. All the bars that were separate for the male are stacked on top of each other. And again, that goes all the way up to 100% because it's 100% of the males there chose one of those options. So let's talk through how to read this. Approximately what percent of female students chose freeze time? So we look at the key, and the key says that freeze time is yellow. So we look over at that right-hand side there, and we can see that. Let me change my pen color so you can see it a little bit better. We can see that freeze time runs from here to here. That is not 100%. That is a little above 80, so maybe like 82. So in order to figure that out, we would need to do 100 minus 82, and that gives us 18%. Approximately 18% of females chose freeze time. Approximately what percent of male students chose super strength? And again, sorry about all the A's there. It seems like it's auto-correcting all those. Should have been A, B, and C. Approximately what percent of male students chose super strength? So we go to the male bar chart. We find the super strength here, which is the orange. And we can see that that's maybe between 33 and maybe about 15. So we do 33 minus 15, which is 18%. So again, that's just by chance here. That was just by chance that those are about the same. 18% of men chose super strength. We can also use this to compare. Did a larger percentage of male or female students choose fly? So we don't actually have to calculate this. We can see that more female students chose fly because the green bar for fly is larger in the female section than in the male bar. So the whole point of making that graph is to determine if there is an association between the two categorical variables. Think back to our original example about anger and heart disease. We would want to track that and see, is there some association between someone's anger level and their heart disease? There is an association between the two variables if knowing the value of one variable helps us predict the value of the other. If knowing the value of one variable does not help us predict the value of the other, there's no association between the variables. So if we go back to our stacked bar chart, we don't have to draw any conclusions about this right now other than to say there appears to be an association between gender and superpower, because knowing a person's gender helps us to predict which superpower he or she would prefer. For example, if I'm a female, that makes me much more likely to choose telepathy than if I am a male. We can see that association in the segmented bar chart because the segments for each superpower aren't the same for the female graph and the male graph. What would it look like if there were no association between gender and superpower? So if I had created my bar graph and there was no association, what would that look like? It would look like two bars that look exactly the same. I cannot use gender in this case to predict what superpower you would choose because everything is exactly the same. So this stacked bar chart helps me to decide whether there is an association or not. Now, sometimes there doesn't have to be a strong association. If we look at this, these aren't exactly the same. We've got a graph here of, again, divided by gender, and how likely someone is to have allergies. So for the women that were surveyed, about 60% said no, they don't have allergies, which means about 40% said yes, they do have allergies. The men were just slightly higher, a little above 60% said they do not have allergies, and a little below 40% said that they do have allergies. We can say that there is a weak association between gender and allergies. We can still say there's association, it's just weak. Knowing the gender of a person only slightly helps us in trying to predict whether or not the person has allergies. Females in this example are, which is it, more or less likely to have allergies than males? Well, the people who have allergies are the red. The women's section is a little bigger. So in this case, we would say that females are more likely to have allergies than males. It's a weak association. It's only slight, but it does exist. So before you finish this out, you want to make sure you take a look at your notes and check to make sure that you're able to distinguish between explanatory and response variables. Might be a good idea to have those definitions handy. I know when I was first learning this, it was hard for me to keep track of those in my mind. Can you read a segmented bar chart to display the relationship between two categorical variables? And can you use that segmented bar chart to determine if there's an association between the two categorical variables? And can you describe that association if it exists? You can close out your notes and have a great day.